Hi, we are still looking at the equilibrium of a particle under two or more forces. Now I have a smooth bead Y, this one here, threaded on a light inextensible string. So the length of this string will not change. The ends of the string are attached to two fixed points X and Z, meaning it is threaded here, but now one end is placed at Z, another end at X. So those are the two fixed points X and Z on the same horizontal level. So meaning the level here from X to Z, that is an horizontal line. So the bead is held in equilibrium. That is very important. When they say equilibrium, meaning forces are balanced. The forces acting in one direction are equal to forces acting in opposite direction. In this case, we may have right forces balancing the left forces, then up forces balancing the down forces. Alright, so the bead Y is vertically below X, as you can see. So meaning this is 90 degrees. And the angle XZY is equal to 30 degrees. So have it as it appears. Then find the tension in the string. Okay, so now we need to find the tension and the weight, meaning the weight is also part of the equilibrium forces. So let us put the forces. First of all, this is our bead. The weight should act down. That is the weight. We have the force to the right, and we also have that tension in the string. Then we have the other tension in the string. So this angle here, because we need to resolve this tension here, is the same tension here, because it is the same thread or the same string. Being the same string, that means this tension, the same tension here, it is the same here. So weight, we don't know the weight. Now since they have talked about the weight, let us use just W. Okay, now we also have to note that this is 80 Newton to the left, but we need to resolve this force here. This angle here, since this is an horizontal plane and this angle here is 30 degrees, this angle is also 30 degrees. So resolving the tension, this portion of the string will be giving us the horizontal component of T cos 30 degrees, because we are moving to the right. Then we have a vertical component of that portion of the string, which is T sine 30 degrees. And that is all. So we need to note that the vertical forces must balance the sum of vertical forces must be 0. So upward forces, this T plus the T sine 30 must balance the weight. Then this component T cos 30 must balance the 80 newtons. So let us see. The necessary equations would be vertically. Now we have T plus T sine 30, that is 1 plus sine 30. If I factorize out to the T, should be equal to the weight, meaning that the tension will be equal to the weight over 1 plus sine 30 degrees. That is the tension. Let us call that one equation 1. Now horizontally, the right component of this portion of the string is T cos 30 degrees should balance the 80 newtons, meaning the tension here can be found by getting 8 divided by cos 30 degrees. So our tension will be, pressing the calculator, the tension is 9.24 newtons. That is the tension. So now let us see the weight. Now find the weight is easy. We already have an equation here. This is equation 2, equation 1. Now part B, from equation 1, our weight will be equal to the tension, which is 9.24 times 1 plus, this is sin 30, 1 plus sin 30 degrees. And now the weight will be equal to 13.9. newtons. Thank you. So that is how we do this number. It is very easy. Please always, if the diagram is not done, begin by doing the diagram, then you do the force diagram, resolve any force which is not pure horizontal or pure vertical. Then you need to note this condition, that it is equilibrium, the particle is in equilibrium, so the forces in one direction must be equal to the forces in the other direction. So that will help you to form equations, which equation is solved simultaneously to find any unknown forces. So I'm teacher Junior Isaac. Thank you for watching. We are still looking at statics, mechanics A level.